Hi, everybody. How many of you are using Spacy now, or who have ever used Spacy? A couple people? Okay, just good. The rest of you will not be bored. So, we're going to be talking about a very thin layer of natural language processing today. Natural language processing is a big thing. You might even be able to get a degree in a very small part of it. So don't expect to leave here being masters of all that you survey. We're going to talk about one thing, and then we're going to talk about all the terrible pitfalls of that one thing, and then we're going to deploy to Kubernetes. So yay! So natural language processing. One of the things we talk about when we talk about natural language processing is we're going to tokenize. We're going to talk about stop words. What's a stop word? A stop word is a word that doesn't matter very much. You can think of it like introns in DNA, right? Like there's stuff in speech. You are all parsing the speech that I'm saying right now, and I'm including sometimes things that maybe might not be a real thing that you want to include. If you were trying to process that in a machine, you would want to clear out all that junk that I just spewed at you and keep the important bits. Now, what are the important bits? That's an open question, but for a lot of systems, you can generally say anything that are called stop words are those things. And Spacy, which is an NLP toolkit that we're going to be talking about today, has support for eliminating those. So here's a little snippet. So these are the glue words and things that can be ignored sometimes. That's the string that we're going to process. We're going to parse it using NLP, which is a loaded Spacy model. And then we're going to put out the lemmatized version of it and whether or not, if it's a stop word or not. So these are all the stop words there. The lemmatized, I just like to say lemma because it sounds kind of cool. Lemmatization is taking and creating the sort of root-based form of a word. So if I say having, the lemmatized version of having is have. This is important, again, when you're trying to build systems that are understanding text. You don't necessarily want to have to create some gnarly regex to generate every variation on a given word. You can just say, hey, you know what? I just want the lemmatized version of it. Here it is. Spacy makes that really easy. In order to process languages using the NLP toolkits that we're talking about, you're going to need a model. Luckily, Spacy comes with a bunch of models, and you can train your own model. That's one of the things we're going to be talking about tonight. Entity recognition. That's where we're going to be focused, sort of, tonight. Entity recognition is how you know that Jason is a person and not a word. If you're trying to extract a bunch of text from a document, you want to know what entities are in that document. What is the document talking about? Are there places? Are there geopolitical entities? Are there times? All these things that we can use to understand programmatically what the text is talking about come from entity recognition and other parsing tools that we have. So you may have heard of NLTK, which is the big grandparent of all of the Python natural language toolkits. That's what NLTK stands for. It's very mature. There's a cool book on it. There's another version of that book that's available free online. And then there's Spacy. Spacy's the big focus is on speed and a good API. It has both of those. I'm generally sort of fond of Spacy rather than NLTK. There are some things, there's some things that one does better than the other. There's things that are supported in one library than the other. Both libraries are big enough, honest to God, to support several distinct books on it. So I can't just give you a quick summary. Here are the things. They're big. They're both pretty good. Pick the one that you like the API of and go from there. I'm going through this pretty fast. There's good news. It installs from pip. You can just pip install Spacy, and you have not everything you need. One of the first things that you're going to realize after you pip install is that you need to download at least one model. If you do not download any models, you will not get anything. Nothing will work, and you'll just be confused and wonder why everything sucks. You have to download a model. Luckily, there's a command line downloader built into the module. You can just do Python M Spacy download N. N is the small version of the library, small and mid, which is a couple hundred megs. They go up from there. Literally, some of these models, when you train them yourself, they can become very, very large. You should become comfortable with very large model files. The bigger, the better. After we do our pip install and we download our model, now we can do something. So that example that I put out first, that quick snippet, that all happens after you install and download the model. You can import Spacy, and then you can create the NLP object using spacy.load, and in this case, n, which is the name of the model. And if it knows where to find it, it loads it, and now you have the full power of that model loaded and available to you. And we can use it. So, hello everyone, I've got some news to give you. So what I want to do here is I want to remove all the stop words from this string and anything that's punctuation, and only return things that aren't stop words and not punctuation. And what the result is, out of hello everyone, I have some good news to give you. You have hello, a pronoun, have, good, and news. This have, there's no have in that sentence. It's I've. How does it know? Lemmatization. These are the hard things about NLTK that the framework provides for you. You don't have to write your own lemmatizer. So now I have this string, this sentence, hello everyone. I have some good news to give you. All the stop words removed. I have hello, a pronoun, have good news. Now I can do something else with that, try to understand it. There are no entities in that, but what if I wanted to find entities, which is really what we're talking about here tonight? There's a built-in entity system that's pretty well trained. It has a lot of entities behind it. For example, hello, Code and Supply. My name is Josh, and tonight we're in Pittsburgh. The entities in this string are Josh, which it says is a person, lucky me. Tonight, which is a time, super handy that. Has anyone ever tried to write like a regex-based NLP for time string parsing? Was it awesome? Did you, when you were done, you just said, this is what I was born for? Like, this is the best thing that ever happened to me? No? No? Yeah, me either. So you can actually use entity recognition to process time strings and to parse that stuff out. It makes it way easier than trying to do it yourself. And there's also GPE. What in the world is a GPE? So the good news is it's going to process the entities and give them to you. The bad news is you have to look at this URL here to find out what exactly those annotations are. Those are the ones that are built in. GPE is a geopolitical entity, I think. Pittsburgh's probably a city. One of the things about this kind of tagging is you'll notice that it didn't pull out. What's the most important entity in there that it didn't pull out? Code and supply. We could train it to do code and supply. We're going to train it on something else. But that's what entity recognition and where the pitfalls of entity recognition comes in. Sometimes, too, it won't necessarily pick up, if you say Pitt, it may pick it up as Pittsburgh. It may pick it up as nothing. It's definitely not going to pick it up as University of Pittsburgh. You would have to train it to do that. The built-in entity recognizer is pretty good. It's basically based on the Stanford Core NLP entity recognizer and has all those entities, but it has some deficits. So far, we haven't seen anything that looked like a tool yet. Like, all of this is code, and there exist very few tools in this space. Most of the tools that exist are frighteningly expensive. And I say they're frighteningly expensive because not only are they super expensive, but most of them don't work for shit. And so you're going to pay a ton of money on a tool that's not going to work. It's a very difficult space. Remember that whenever you're doing any kind of entity recognition, any kind of NLP. So now we come to the important part of our presentation tonight. We're going to train a model. I should probably stand here, right? Because of the audio. All right. There are a whole bunch of caveats. This is the sad part. This is actually one of the sad parts of the presentation tonight. In order to train a model, it takes a lot of computing power to train one that's any good. You may even wish to fire up a 16 processor high CPU cloud entity to do this. We're going to do this tonight on my little laptop here because we're basically playing with toys. But if you're doing any kind of real entity recognition or real model training, you're going to want some computer time available to you. Remember that, because in order to effectively train an entity model in Spacy, you need at minimum 200 examples. This is part of the reason why we're not going to train on code and supply tonight, because 200 examples is a lot. And I don't mean, yeah.
Sorry.
Yes. But that's a minimum. That's an absolute minimum. And honestly, I think they put that in the docs just to, because that's the first question everybody asks, right? Like, how much data do I need? 200. That sounds like a lot. 200 is a bare minimum. It's unlikely that for a lot of situations, depending on what kind of entities you're working on, that 200 is going to be remotely enough. You need a lot. You need like Mechanical Turk spending hundreds of dollars a lot in order to get any good results out of this kind of stuff, at least on things that aren't very regular or very, like, if you're trying to parse an entity out of, very regular text, there's a very formal wording or something like that, maybe you can use fewer. But if you're trying to extract entities like out of a Twitter feed or something, you're going to need a lot, and it's going to take a while to train, and you're probably going to you're probably going to want to be spending some quality time with Mechanical Turk. That's pretty much what everybody does.
When you say regular, say for example, a finite set of log messages out of varying purpose.
Yeah, if you had like a structured log that were generated by computers, but something like that you could probably get away with less there. You're trying to parse nurses' notes from trauma centers. You better buy some gear and hold in for the next couple months, because it's going to take you a while to train that. There are some things that you can do to make it easier. We're going to talk about some of that. But like I said, you may want a VM. All right. In order to train a model, and this is just training our toy little model, we're going to want some imports. We're going to import Spacy. We're going to import Plaque here. Plaque is mostly there because this thing is going to run as a command line tool. Plaque provides you a decorator that allows you to easily write command line utilities and pass in arguments. I use it. It's pretty simple. It's not super germane, but there it is. We're also going to use in Spacy, there's a thing called the phrase matcher. Now, one of the biggest hard parts about training these entities are you need to put into the system the indexes for the string that you're looking for. So if you have a string, that's, hello, today I walked to the store and the store was named Tesco, and Tesco is the entity that I want to recognize, I need to pass in that string and the index of the token in the string. Now you can count that by hand. It's kind of a pain in the ass. Spacy provides this phrase matcher thing, which lets you put in multiple versions of the string and find out where it is in the string, so you can extract out its location programmatically rather than having to count characters in a string. Yeah.
How does that work?
I will show an example. So we've got some imports. This gives us the phrase matcher. We're also going to have a utility function. This utility function basically converts, the phrase matcher is going to convert word position in a document parsed by Spacy into string position in that string. That's all this does. And it provides the label. Okay, so the next step is we're going to load our model, and then we're going to make sure that the NLP pipe is in there. This is, again, this sort of boilerplate, because we're just training the named entity recognition. We don't want to gum up the works by doing anything else. We just want NER. And if it's not there, we want to make sure we put it in there. And so here's how you handle the multiple phrases. So what we're going to do, because again, you need a ton of data, right? News items are perfect for finding named entity recognition, because I guarantee you that there are at least 2,000 examples for Gina Haspel, who's currently the director of the CIA and was recently up for the Senate confirmation. I guarantee you're going to find a lot of data for this person. So I want to make sure that Gina or Haspel, all three of those things should resolve to the entity CIA director. Okay. So what we do is we just add each one to the phrase matcher. It's parsed using Spacy's document parser, and the matcher takes a document parser and a label. The label in this case is just any string that we want. This is the new entity that we are training this system to recognize. Okay? And you can do an arbitrary number of these. I would say if you find yourself with a whole bunch of these strings, these tokens in here, that maybe you've got more than one entity there. But again, this depends on your data, right? Like again, if we go back to the Twitter example, words for bad people, for example, if we want to extract an entity of an idiot, for example, that's going to be a bunch of those if we're using a Twitter data set. But maybe you have more than one. Maybe not. What's this actually look like? Okay. Gina Haspel was nominated in 2008. We take that matcher, and if we look at the matches, this number here is the representation of the label that we've passed in. You don't have to worry about that. Just map that number to whatever label string you used. That's an arbitrary thing. The 0 and 1 is the word position in the document, not the string integer position. That's why we need the utility function here. Everybody remember that? Because this will easily mess you up. It frequently messes me up too, because you get the index back and you're like, oh, I have a string index, and it's not a string index. You have to convert it. Okay. So now we get some data. Like I said, this is a current political thing. There's a ton of news articles out there with this person's name in it. You can go on any website. You can strip them out. You can actually use Spacy to parse paragraphs of text into sentences and then use the phrase matcher. So you can actually write your own crawler that will go out and harvest things. That's a little beyond our example here. But the phrase matcher and NLP can parse text documents into your training data. I have, in this case, already just created a text file that has all these sentences in it. The sentences themselves don't really matter, but you could go out, find them, parse them. We're going to gather up all that data. We're going to use the phrase matcher that we set up before to actually calculate the positions so that we can pass that in to our training system. And then that's just going to create a new array of that string and the positions of that token. And this is where we actually begin to train the recognizer. So first, we pick an optimizer. Luckily, Spacy comes with a built-in optimizer for us. We don't have to provide one custom. You can if you want. That's in the category of what I generally refer to as master's degree projects. So that means when you're done, you can publish your work and you'll probably find somebody who'll give you a master's degree on it. So we're not going to cover that right now. You can just use, for 98% of things, you can just use the built-in optimizer and understand that people that are better at this than any of us have put the recognizer. Then we're going to go through the pipes in NLP and make sure that only the named entity recognizer pipe is there for the training. And then we're going to iterate through, we're going to go through this 20 times. I'm going to go through the training data 20 times. And we're going to shuffle the training data, and then we're going to pass this update function. This is where the magic happens. So this update function takes the model that you've loaded at the beginning and updates it with the new information about the token, the position of the token, and the string that you're trying to parse. And every time it updates it, it's going to move down the gradient using the optimizer that you passed in, and hopefully get a little bit better at recognizing that named entity every time. Now, when you watch it, you'll see that the error bounces around. The error rate is from the last run. So sometimes when it goes up, it's not really going up globally. It's going up along the minimum for the path that you're currently walking. You raise your hand. That's correct. Because that's easier. And we don't have a whole lot of training data. If we had a ton of training data. So the other reason is because Right. Yeah, it does. Even seeing the same stuff again will reinforce it. The why it's 20 and not more than that is the documentation's a little vague on this, but it says that there's a point where if you do it too many times, it will forget all the stuff that it knows now. There's no guidance in the documentation about how many times is too many or too few. The documentation just uses 20 in its example, and so I did too. But yeah, I'm sure there's a reason in there. Like I said, the documentation's a little vague on that. Right, so we formatted the data in our toTrain, and we pass it in with the optimizer. The drop is basically the cutoff between whether or not it updates itself. And then we're going to print out the loss. And so let's go ahead and run this thing. Let's try to be in the right virtual environment. Whoops. I may have. One moment, please. I think I messed up my. Okay. So while this is running, I'll have a chance to talk about it. And so, really blurry. All right, what this is doing is it's running through that loop that I put in earlier. It's running through the training data. It's shuffling it. It's running through it a bunch of times. It's training it. Hopefully, when it's done, it's going to run against the training data that we've already got, and hopefully it will find an example, an entity in it, because as I mentioned, you need a lot of data. The toy data that I've got in here is actually an example of, so there's maybe 50 or 60 items in there. That's not enough to reliably get overtrained results. So you can think about that. It takes a lot of data to train one reliably. You'll also notice, okay, hey, found one. So in this sentence, it found the entity CIA director after 20 iterations with the data that we've got. That took not very long. That's a tiny, tiny smidgen of data. Yes? Well, if you don't know the target names, then named entity recognition is probably not a good strategy. You want to be able to extract known entities from existing text. If you don't know the entities, then you need to do something else. Okay. Yep.
Just said the
Yep.
all those from.
Okay.
So
you need to find a data set and tag every name in it. I mean, that's how a lot of the named entity recognizers, they just have, 100 megabytes of sentences with names in them, and they're manually tagged data that they then train the recognizer on.
for
The difference is that
if I turn all those characters lowercase, then I just also find.
you can. That's certainly one approach to doing it. The benefit of using your own labels versus using the built-in labels is up to the problem that you're trying to solve. A lot of times the entities that you may want aren't necessarily in the named entity set that comes with Spacy.
Right.
So you want different labels. If you want names, then you're just going to need a boatload of data with names and have them tagged. The benefit of using this versus just straight token searches, one of the biggest things about using this versus straight token searches is things like apostrophe S's, Haspels. There are a lot more variations on text than when you first start out. Unless you guarantee that string is always going to be the same, it's probably faster if you know that those entities always have the same representation to just do it that way. But a lot of times that's not how the data works.
I was thinking,
Yeah.
Let's say if we want to extract all the university names from a bunch of texts,
Yep.
and let's say if you just input University of Pittsburgh
Mm-hmm.
in your training data,
Yep.
then probably you can never find CMU out of the text, right?
No, you'd need CMU in there also. But then,
Maybe you'd also need Carnegie Mellon and who knows how many from I bet
Yeah.
there's only 2 forms.
yep.
Sorry, I suppose I still don't understand it because so you need a bunch of training data. So to go back to the CMU example,
Yep.
you need CMU and Carnegie Mellon, and you need it to be labeled.
Yes.
And I assume you need multiple instances of it in different texts.
Yes.
So why not? If you already have the labels, why not just do a search on that? Sorry, it's like a really dumb question. I suppose I don't.
No, it's not a really dumb question.
Why?
It's part of, so when you are attempting to analyze diverse document sets, a lot of times the strategies that you would normally go through using regular expression search start to break down because the text volume that you're dealing with. So yeah, if you only have 10,000 documents, absolutely, regex, rock on. Just put in, if it's CMU, you've got 5 different styles of having it, go ahead and do it. The problem is when you're starting to examine 10 billion documents and they're in an inverse, like let's say you've got them indexed, right? And so now all of a sudden you have Carnegie Mellon University that may be 3 words, and all of a sudden the regex stops working. So you can do Carnegie, but then you're going to get Carnegie the town, you're going to get Carnegie the guy, you're going to get Carnegie the library, and so you can start to winnow those down. But what you really want is just documents that contain the entity of Carnegie Mellon University. And so then you can put that on the indexer side, and you can start to do entity searches rather than just string searches. Does that make sense?
So
Nope.
you're saying by training it, it's more likely to recognize the variations, like say for Haspel, if Haspel was misspelled, is it more likely to recognize that it's still Gina Haspel even though it's slightly misspelled? Or-
Yeah, I mean, you need that in your training data,
Okay.
common misspellings. But
Is part of the advantage that you're not necessarily just searching for CMU? I mean, you're trying to process much more of the data to get a lot more, I guess, meaning out of it than just a single. So this is an example of adding to a model, but the power is in the whole of the model or the whole of the things you can do with the model.
yeah, I would say yes to part of that. And then you had
Can you say that the Spacy name entity recognition of the Spacy also use the context information to recognize the entity or no?
It does, yeah. That's why you need so many different, it's not just the text. It's going to parse the document and say, it usually comes in as an adverb, or it's, this part of speech, or it builds up a model of all those things.
And for context information, do you mean, for example, n tokens after the entity or n tokens before the entity as the context for the, for example, for the CMU in a sentence?
I don't know if it uses, it probably does. Yep.
I mean, just giving you, so CMU, right? CMU, we're like, oh, CMU, it's got to be university. CMU is also an abbreviation of concrete masonry unit, like a concrete block. Like, that's also called a CMU. And so, yeah, like just seeing just the string CMU and like you said, super diverse text or stuff off the web, doesn't necessarily mean it's Carnegie Mellon, right? Like, and that's like Brandon, and there's much more ambiguous words.
Yeah. The example that I usually use to explain why you would care about any of this stuff is, let's say you're in an e-discovery for a law firm, right? And you've got literally like 5 billion emails. And you need to find every email that talks about Madoff as a person, not as the firm Madoff. You cannot execute that query using regular expressions. The amount of information that will be retrieved will overload anybody. You need to have a way of querying the data that returns not just that that string exists, but also that item, that entity exists within that document that has a particular context. And that person, that context would be a person and not a firm.
So then are there other things when you're training the model that are equally relevant? Here's the string, but also here's more information about the context that I'm interested in about this string.
Yeah, you don't tell it that. It is why you pass in documents, is it's parsing those documents using Spacy. And so information about what part of speech it's used, where the dependency graph of the sentence falls in, all that kind of stuff, that's all used by the model as well.
And then you pick the ones.
Single sentences usually, or do you need it like longer?
Yes. That depends on a bunch of stuff. Not just your problem. It depends on how much data you have. It depends on, it totally depends. Because you can pass in, when you train it, you can pass in any NLP, any Spacy document with any number of entities in it. So you can use big documents, you can use small documents.
So you can train it on multiple new entities at a time.
Yes. Yeah, you don't have to just use one. We're just using one because otherwise they totally don't fit on a slide. Yeah,
I also had
and
a
then-
question about context, but
Yep.
if you go back to your phrase matcher, it'd be in the context of your example.
Okay.
So yeah, I mean, this is a simple example. So, but so just having Gina or just having Haspel
Yep.
might not be good, but Gina Haspel should be pretty good. But is there any way where you can pass in maybe Gina, and there's also an entity like CIA in this, or provide other context information to the phrase matcher?
Not for the phrase matcher. The phrase matcher is purely at a token level.
Okay.
At a document level, though, certainly you could classify those documents based on just for the set of entities, for example.
Okay.
If the set of entities includes Gina Haspel and CIA, then this is a document about the CIA. Otherwise, maybe it's about something else. Does that make sense? At this level, it's just that you would have a separate phrase matcher for CIA and Central Intelligence Agency and whatever else, Quantico or whatever else you want
We
to.
already have an entity
Right.
for CIA, and then
Yep. Yep.
And does the Spacy convert the word to the vector or just use the word?
Spacy converts it to the vector.
Okay.
And Spacy includes, I mentioned Computer Lab, I mentioned some Gui tools. Spacy has really good support in Jupyter. So, for example, these entities are highlighted and displayed visually in Jupyter automatically. So you can do that. You can also it doesn't show up very well, but I mentioned the things about relationships and parts of speech and dependencies within a sentence. This is actually the dependency graph of the sentence. In this case, the unveiling of her official agenda on Monday, it was almost as if the First Lady, in speaking out on behalf of American kids, was really advocating for herself. This is the dependency graph for that sentence. And as you can see, it's pretty large.
To do that in a chalkboard.
Yes. If you're of a certain age and you were educated in America, you did this manually. They stopped doing that because computers do it way better.
It's not what it's done.
Oh, so like another use case, we keep talking about CIA, for training your own thing like this might be finding mentions of people in phone transcripts,
Yes.
emails.
Emails. That's my e-discovery usage. I mean, the base package for Elasticsearch like includes named entity recognition, and for e-discovery, like you can, yeah, thing's a freaking chainsaw for that kind of stuff. Yeah. Chainsaws are good, by the way. Chainsaws are good if you have a giant forest and you want to cut everything down. Chainsaws are bad if you're trying to cut cake. So you just have to ask yourself, am I cutting cake or am I cutting down a forest? Okay. But the Jupyter integration's pretty sophisticated. It's also very sophisticated for the things that it does, and that is all that it does. And if you want more, the Spacy organization has a couple of tools that they sell that do some of this stuff. But this is pretty good. Okay, where was I? All right. So now we have a trained recognizer that works. That's it, right? We're done? How many of you don't ship code? Nobody? Good. So we want to actually ship this. We want to turn this into a service because this, everybody here, you're all going to get shares in this new venture. I've applied for YC. I think it's going to be huge. It's the CIA Director Recognizer for strings. We're going to deploy it to Google Cloud. I've got a press release already set up. All we have to do is Dockerize it and create a Flask application and push this thing out. Okay, so that's super easy, right? How in the world are we going to do that? Okay, so the first thing we're going to do is we're going to shut down our Jupyter server and look at our Docker file. And this Docker file right here, okay, so we're going to use 365 Python Alpine image, which is a pretty small image. If you've never seen a Docker file before, this is it. There's no magic here. There's just poorly documented syntax that doesn't really follow any traditions from Unix, and so it just seems a little weird. So we're going to say our image is based on the 365 Python Alpine image, and we're going to create a workdir. And what workdir says is everything after this point, the base directory is this workdir. So it's going to be /app. And then we're going to add our app.py, which is our Flask application, which I'll show after this. And then we're going to install GCC, MuselDev, and C++ so that we can compile all the crap that we need to for Spacy and everything else. Then we're going to add our requirements.txt. And then we're going to install those requirement.txt. And these run commands execute inside the container that we're building as we're building it. So this doesn't run on your machine, it runs on your machine or wherever you're running it, but it runs within the Docker container context. So when it installs all this stuff, it's actually installing it right into the container, and you don't have to copy anything out. You just run the build command and it copies everything over. We're then going to copy over our Gina Haspel model, which we generated in our training event earlier. And then we're going to copy over our config.py, which tells GUnicorn which port to run on. And then we're going to expose a port. And expose tells the Docker system, hey, I'm going to want this port open, so please open it. Yep.
Maybe it just means you have add.GinaHaspel space .GinaHaspel twice.
Yes, that is how you copy the contents of a directory into another directory.
Oh,
The
sorry, I didn't mean to ask a picking question.
No, that's fine. It's like I said, this Docker files are kind of goofy, and if you only have occasional interaction with them, they can seem really daunting, and they're not. That's how you have to do it. If you don't do that, it'll do one of 8 different things that you don't want with regard to copying those files. And then the command, and the command is actually what gets executed when we run this container. And this command is gunicorn config, using that config and the Flask application that we're about to see here. So if we look at this Flask application, you'll see that it's not a super complicated Flask app. So we import Flask, we have Spacy, we load our base model up there. We say for the route ents. You know what? That is impossible to read. Better?
Yeah.
Yeah, if I stop making sense, say something, because I may not know. Okay, so we have a route, which is /ents, which we're going to hit whenever we want to do entity stuff. And if we have a custom flag passed in, we're going to load our custom Gina Haspel model. If not, we're just going to use the basic English model. We're going to pass in a fragment, and that fragment we're going to analyze, and we're going to return all the entities from that fragment that gets passed in, either with the base model or with our custom model. We're also, for free, for customers signing up during our beta period, we're going to provide a stemmer. This is the big win of our new startup, is the stemming too. And so we're just going to remove all the stop words and punctuation from any string that gets passed in, and we're going to return that. So, okay, that's our Flask app right there. Don't tell anybody. That's the secret sauce. We're going to run this Docker build command, and I'm not going to run this because it takes a while to build the first time, because it has to download a bunch of stuff. And you may notice that this does not look like Docker Hub. So that is the Docker repository for Google Cloud. And why we're using that is because we're going to push this up to Google Cloud, and we're going to deploy it in Kubernetes so that it's in Google and we don't have to push it to Docker Hub. So once it gets built, we're now going to execute. Who thinks this is a reasonable number of commands? Neither do I. That's why they're on this slide, because it's kind of ridiculous. But once I tell you, it won't seem so ridiculous. It'll just seem tedious. All right. So after you install the Google Cloud software, you init, and basically you log in. That's what the gcloud init is. And then we're going to auth configure Docker, which is going to tell Google, after we've approved it, that we should go ahead and allow our user account to push into their Docker repository. We're then going to print out the access token for that repository, and we're going to cut and paste that into a Docker login, which is right here. And then we're going to push that container that we just built up into the Google system. And after we do that, we're going to create a new cluster using their Kubernetes system, and the cluster is going to be called Experimental AO1. And then we're going to get their credentials for that, and then we're going to use kube control, and then my slide runs off. So I'm going to have to go over here. Then we use kube control to control the cluster that we just turned on. And we're going to run our stemmer server using the image that we passed up, given a certain port. We're not done, because then we have to tell the cluster that we need to expose the ports using a load balancer. And then we're going to get where the service deployed. And once we do that, then we can actually hit it. So let's go ahead and run through this. So we're going to...
How many steps would this be with AWS?
Oddly, it would be slightly more. But they would have better names. I'm a little irritated. Here, I didn't mention this at the beginning. So I will wander into fact and opinion without signaling. So you can just pretty much assume that everything I say here tonight is my opinion, not fact. I use AWS every day for my work. I really like AWS. I find Google Cloud to have a couple of things that is really awesome. Does anybody work for Google Cloud here? Okay, good. So I don't want to be like, because that's not what it's about. But Google Cloud's interface feels like somebody was described what a cloud interface should be, and then they wrote it. And they had never used one. It's like the old Star Trek episode where they found the person, and the aliens had found this person who'd been in a terrible accident, and the aliens didn't know what a person looked like. So they put the person back together, but they put them together wrong. They were alive, but they were wrong. That's Google Cloud. It's like the aliens put the person back together kind of wrong. That being said, their Kubernetes interface, this is hands down the fastest way to get a Kubernetes cluster up and running anywhere, bar none. Like, this is pretty easy as far as those things go. So, your mileage may vary.
Will you post all this somewhere later?
Which? Oh yeah, it's all in the GitHub repo.
Great.
Like
the slides and all that?
Yep. Let's see. We want to do. We're actually going to cheat a little bit. And the cheating that we're going to do is so that I don't have to display my password to you.
Please don't. We won't tell.
Yeah, you won't tell. I've heard that before. Login succeeded. All right, we've already pushed it. This is not free, by the way. So if you do this, error. Oh no. Okay, this is a good example. The one super nice thing about Google's command line interface is that when it gives you an error, 9 times out of 10, there'll be a URL in the error that you can go to fix whatever it is that's telling you that's broken. So in this case, it's saying, hey, this API is not enabled. So I can click on it, and here I am, and I can go ahead and click enable, and now that command will work. But that's what I mean by it's a system written by somebody who's never actually used one of those, because why didn't it just give me an option of doing it right there? I was clearly running that command. Okay. All right. Well, this is going to take a little bit longer, so we're going to skip ahead. Anyway, skipping ahead is just running a couple of Docker commands. Questions?
I'm trying to identify equations like embedded in text, like Newton's second law, like
Okay.
net force equals mass times acceleration. There's all the different variants. Currently, I have some regular expressions that work and seem to match all of it. Would it be overkill for me to do this?
Do you know in the documents that you're working on that there will always be an equation?
No, I suppose. Suppose not.
There's probably an easier way of doing it than using named entity recognition. So regexes are not a bad. So identifying non-linguistic artifacts in documents it's not necessarily a good idea to try to shoehorn a non-entity into an entity. Like an item in a document isn't necessarily part of the language of the document, if that makes sense.
Yeah, I'm just addressing it.
Yeah, no, that.
Normalization
Mhm.
phase.
What I would say is that it would certainly be really easy to speed up your process by using Spacy to eliminate all language in a document, and that anything left might be an equation, and then be able to operate on that. And to be able to tell, is the language of the document referring to, can I infer from the language that there exists an equation somewhere in this document? And from that language, can I further infer where it might be? And then I can remove anything that's a word or punctuation, leaving behind something, and then go from there.
It's true, all I care about is whether they had the equation and it's correct.
Yeah, and that's where a lot of NLP tasks tend to fall into two buckets, right? Like one is finding stuff in the document, and the other is finding out if something isn't there. And one of the easiest ways to do that is to remove everything that everything that I know what it is, and it's not what I want, I can remove and go from there.
Thanks.
Yeah.
Yeah, so what's the actual underlying model that's using?
Like SVN versus something else?
Neural CRF?
I don't actually know. That's a good question.
I think for Spacy, it's just a general CI, but for the Stanford core NLP, they're using CI.
Can somebody like to translate those into some English that I also want to understand?
It's the methodology for actually constructing the model. So I'm pretty sure they just straight ported core NLP to Python.
Actually,
No?
no.
Oh, well then what did they do?
Because we need to pay for core NLP. They have a commercial license for that. But Spacy is totally open source.
I didn't know that.
Can you repeat that just a little louder? I didn't quite hear that.
Oh, what he said was you have to pay for Stanford core NLP. So Spacy is not a straight port of core NLP because they would have to pay for that. They did their own. Other questions that I might be able to answer, or someone else in the room can? No? All right, yeah. All of this stuff is out there. GitHub, Cognate, presentations, code and supply. Misspelled my own. GitHub.com, Cognate. Code and supply, Spacy, NER. All of the code, the examples, the Jupyter files, the Docker files, the presentation.
In Emacs.org, org file, the presentation.
Yeah.
Pretty cool.
It's a Beamer template using the Pittsburgh theme.
All right.
It's actually, it's even worse. I used Tangle, so we're way off base now, but it's actually literate programmed for certain values of literate.
Cool. So I will post this to the meetup group, link to this, and like I said, if you came in late, like there's people came from all different sources, whatever. There's a Pittsburgh Python meetup, and we'll have like specifically this kind of stuff. Anything?
I don't think so. Who's presenting next? You? You?
Yeah. Well, so I can. Yeah.
You?
No, we got people lined up. Thanks.
You
thanks
do?
for watching.
Oh.
No, not to me. Just immediately now, but just next month and so forth.
Well, no, I would have pushed less hard if I'd known there was somebody
okay,
else.
Well, let's talk about what's coming up. So thanks, Josh, for.